So a bit about me, just so you know, kind of background-wise. At the moment, I work as a full-stack JavaScript software engineer. I work for a company called TES, which I'll just say briefly a little bit about in a minute. I'm in the lucky position that I work from home. So I live in Bath. I used to commute to London for years and years, and I hated it. And the main reason why I've kind of made the shift away from consulting and back into development is so that I can work from home, and it's great. My commute is go downstairs or come back inside from outside. And my background and why I propose this topic is because about 20 years ago, and that seems like a really long time ago for probably most of you, is that I was one of the first people in the UK interested in extreme programming and test-driven development. So I have an interest in testing. We were using JavaScript at the time, but JavaScript was a very different language. So I won't say how we were using it. We were mostly pushing all the logic to the server side so that we could test on that side and not testing the front end. The company I work for, so TES, people who are involved in the world of teaching, they have heard of TES. And pretty much anyone else you speak to has never heard of TES. And they're like, what, TES? What's that? Was Times Educational Supplement. I think we still publish that publication. But now our website is for teachers to find jobs and teacher resources and stuff like that. It has a great architecture where it's actually all microservices based. It's all JavaScript. Front end is typically React and back end Node. We have lots of tests. We have lots of continuous integration. We have about 50, I think it's 56 or something, engineers who work there, and most of us work remotely. So we have to figure out how to do things when we're not all together. So tests can help sometimes. And we have this remote first culture. So we have some ways of working that help us basically not bunk off all the time and actually be focused on what we're doing and not forget people are not in the office. I tried to think of what an introduction to unit tests would be, and I thought, well, what's a test? Well, so because I was actually sitting next to somebody last time who didn't know what a test was, and that's fair enough, because I think lots of the tutorials that you do with new JavaScript frameworks, they kind of, I've even seen some that say, delete these tests that, you know, create React apps, creates for you, and things like that. So a test is some code that you write to check that your production code, or the code that you're actually going to deliver to people, is working. So you write a program to test a program. But then the good thing is you don't have to go click, 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 and keep trying to reload and reload and reload. So the idea is that you use your coding skills to help you check stuff is working. But when people talk about unit tests, what unit means is pretty vague. It's something smaller than the whole thing. So people, when they are testing from the outside of the application, they're usually talking about acceptance tests. And when you're talking about testing a component or testing a function, these green things are meant to be the tests. These brown things are meant to be the production code. You might just carve off a piece and say, this is a lump of code that I can test with by writing a program. There are many test frameworks. I don't have a favorite. I'm not going to extol the virtues of any particular one. Probably the examples I'm going to show you are in Mocha, using various different assertions and stuff. Here is a simple test. I don't know if you can read the code there, but basically this test here. So I was trying to think of something that's a very easy thing, right? So the outer block is you write something that describes what you're going to test. So that it's you're describing what an array does. Then inside of that, array has various different functions. So you might then pick one of those functions and then have the different scenarios that that function would respond to. So for example, array index of. So in my first example, right, if I have an array and it has a banana and an apricot in it, oh look, and there's a typo in there. So I did fix this typo, but then I obviously didn't. There should be a quote there and a quote there. These should be 2 strings. But whether there is a string with a comma in it or not, if you look for an apple in the array that doesn't contain an apple, you should expect it to return you -1. So the idea is that you have your subject to your test, then you invoke the thing that you expect to happen, save the result, and then check it matches what you expect. And you tend to write tests for the abnormal scenarios and the normal scenarios. So like the abnormal scenarios, I'm looking for a thing and I don't find it. But the more normal thing is like, oh, I am looking for a thing, what should it give me? So, and then this is slightly counterintuitive for people who are not thinking about zero-indexed arrays. So if I have an array of 1, 2, 3, and then I do index of 3, I expect the result to be 2 because it's 0, 1, 2. So this is a very simple example of what tests look like. I did some Googling around for definitions and things, and I thought this is a good way of explaining how you tend to structure a test. So tests tend to have the beginning, where you're getting the thing set up in the world is before you try invoking what you're going to try. And then, so you arrange, so you set up your preconditions and inputs, you act on your component or your function, and then you assert, you check, what did I get back? Is it what I was expecting? And then the idea really is that you can build all of these things into suites so that you can run lots and lots of tests. And here is an example. I just put some comments in on the previous test to kind of illustrate. So range is the beginning part, where you say, I'm creating this array, and this is what I expect, and this is the value of the thing I'm expecting to get back. Then you have your, I'm calling index of on my array under test, and then you at the end have, here is my expected result. So it's just a way of structuring, and very often, and I probably in the next example, you'll see people collapse this right down, and then sometimes it's harder to see what the test is really trying to do. But it can be, especially when you're new to writing tests, it's a good way to start. So as somebody who's used to writing lots of tests and working in code bases that do have lots of tests, because I've been working in the world of Java and not JavaScript, it's really quite strange to come to JavaScript and you're like, there's loads of big code bases with not many tests, and you're trying to figure out, what does this do? And it's really nice if you have some tests, because the tests actually give you some documentation. They say, this function expects to get data of this kind of input, and this is how it handles it. And here are the error cases it's expecting to handle, and this is the kind of way that you would expect to interact with it. So one big value, apart from the value of making sure your code is still working, is also leaving some documentation behind for the people who come along afterwards who are trying to figure out what your code does. So that's one of the things that's valuable. And this talk is about the hidden benefits of unit tests. This is not a hidden benefit. This is one of the more obvious benefits. So, oops. So here's another example. And I just took this from one of the projects I was working on in the summer. So it's, and you can see how it is not really broken down into those 3 A's at all. It's just like one line. So, but what it's doing is quite a useful thing, which is it's explaining the validation function for email addresses, how it works, and what you'd expect to happen. So the first thing is it's kind of counterintuitive, because a validation function gives you a text message when it's not a valid thing. When it is a valid thing, it doesn't give you anything, because it's giving you an error message to show. So if you have an invalid email, then you expect it to give you a message. But if you have But one of the interesting scenarios kind of is, what does it give you if you give it an empty value? Is that invalid or is that valid? And so in a way, this documents and helps you to see that's what the email validation does. If you have an empty thing, you won't get a failure, you'll get undefined. So that's just a small example. Now, because my background is more from outside the JavaScript world, I read a lot of the work of Martin Fowler back in the 2000s, and he has recently actually published a book about refactoring. He's republished this book, which was originally published, I don't know, back in 2000, but has now republished it, and he's filled it with JavaScript examples, which is great. And he talks about, in that book, his thinking process around how he develops code. And a big part of his thinking process is how the code is developed with tests. And this is one mindset that people have, is like they actually write the test as they're writing the code, rather than writing a lot of things when it's working going, oh, I'll just write a few tests afterwards. So this idea that you would write the tests as you go along. And he explains that for some tests, he had this idea that when you're trying to think what is a unit, it can be a function totally isolated on its own, and you give it fake things, so it doesn't really know. It's not using any of the rest of the application. You give it what people call mock objects, stubs, but you have a way of detaching it from the real world. So you're just literally testing this thing on its own. Or the other style of unit test is you're testing the function, and it is you really using the other things that it would normally collaborate with. So you're testing more than just one thing, you're testing also the other things that it's working with. So there's a word for this that didn't originally exist. I was actually working the first company where they came up with the idea of mock objects, but as it turns out, there are different ways of faking out reality when you're testing a small thing. So one thing is to write some code. This is a stub. For a stub is where you set it up so that it acts as the thing that's supposed to be there, but it always gives a particular response. So you can say, here's your response, give it back. And then you have other different flavors. And the thing is that when you actually look at the different frameworks, they don't really map to this anymore. So you have, for instance, spies that can tell you whether they were called. And a thing that what you find is that quite often these terms are used interchangeably, but they do actually have a more precise meaning. So sometimes people say, oh yeah, just mock that out. And they might mean write a stub, write a spy. And then actually in JavaScript, there is actually different frameworks you could use. And those different frameworks might have the option to do these different things. So I'm not saying this particular mocking framework or this spy framework is better than the other. I'm just saying be aware of it, because it's one of the things that can be very useful when you're writing your tests. And I will give an example recently on a project where we've been using GraphQL, where we've been using mocks to set up the GraphQL part. So I can't remember whether that comes next or not, though. Yes, no, something else comes next. So this is what I've been recently working on. And so this is just writing unit tests for just a simple React component. So I've been working on an image uploader component. But the design I've got, I haven't got the whole of the design here, but the design of this component is, if this component is initialized without an existing value, it shows like an upload button, because like your option is when you don't have a value, upload something at least. But once you've uploaded it, it should display in this format at the bottom, where it shows, so this is like a little thumbnail of what the image you uploaded was. Then there's the name of the original file, not the URL. Then there's like a little trash can button. So it's the kind of component that's slightly annoying to write because it's both this kind of button and this kind of button. And so you can't, and then even if you write a file load upload, you have to, it has if you use the native component, it has a message which says something like no files chosen, which is like total ungrammatical English. So you have to kind of hide it. So you have to remove the style of the thing that is actually there and then put something on top of it. So because I was developing this thing, I felt, well, normally we would have acceptance tests, but in this particular case, it'd be quite handy to be able to just check that the right things are appearing in the right situation. So this was a case where I did write a unit test for it. So here is my unit test. I don't know why it has stopped doing the color formatting, but basically, so the first case is if you don't have an image URL when you construct this image input, then you expect there to be an upload button. The second scenario is that if you do construct this image input with a URL, obviously of a kitten, then you would expect to see the kitten file name there, and you would expect to have also something that allows you to delete the image. And then you would also want, once you've clicked the trash can button, you would expect to be back in the first state. So although these are not very fancy or complicated tests, for me, it's quite handy to have that to make sure that that bit of logic is still working. I can just run the test, make sure that I have not broken the two states of this component. If you want to read a bit more about testing React, there is a tutorial by one of my colleagues about with much more detailed examples. And I don't want to give like too many detailed examples because I know that that can be a bit kind of grueling if you're listening to a talk. So here's the GraphQL component. And again, I'm not going to explain too much about the context. I really want you to get the idea because in where I work, we have a front end component written in React. We have a back-end node component, which then calls to the database. We're introducing GraphQL. GraphQL is a means for you to send queries to the back end. So instead of a typical REST endpoint, the back end exposes just this GraphQL endpoint that you pass queries and mutations to. But then that could lead you to think, well, I have to always build the back-end part before I build the front-end part. And actually, you don't have to do that. And there's a more lightweight way of working. So what we've been doing is we're using this mocked provider so that we're able to mock out. So this is like create a fake GraphQL world that this thing that we're testing thinks it's talking to. And it enables us to then structure the query so that we can figure out how the query should look before we then go and implement the back end, which actually then goes and calls the MySQL database and gets the particular fields. So I'm not sure how far to go through in detail this example, but I will explain a little bit. And we could come back to it if you're interested. But basically, and then there are probably some concepts in this example that you may not know. So the project I'm working on at the moment is something where we have a workbench where people in the marketing team can create campaigns to run across the site. So we have this concept of slots on pages, and we have this concept of components that can be allocated to slots. So that's the domain that this example is in. So we've created some fake data. There is a super cool component, and there's probably yet another cool component. And these are then we can mock out an empty query. So we can say, we can declare a query that basically, if you give it a slot ID, doesn't return any components. This then enables you to write a test for this. And then we have another mock empty query without a slot. So this is like, if the slot ID is null, then again, return nothing. And then the final one is, right, now we've got a query, and we give it a slot ID, and it actually does give us these cool components. Right, so you set up this mock data. This means that you can write the front end without having to do the back end part first. And it means that you can work on these things independently. And actually, when you're using GraphQL, I don't know, is anybody in here using GraphQL? I don't know. Yes. So one of the things that you find is that, because it's like a query language, you're trying to think, how do I want to express this query? What do I want to do? So this step of writing the tests and writing the mock queries helps you actually to design what queries you want to build. Because it would be very easy if you tried to go and build on the back end first, for you to assume that you needed a lot of information that you don't necessarily need. So this way, and this is actually very much a test-driven development. People talk about test-driven design concept, but basically, when you write a test, you are the first person calling the code that you want to test. And so you then think about, well, what should it be called, and what should the arguments be, and how should it relate to the other things? So actually writing the test is like a design step, but it's a design step for writing your code. And so this writing tests using mock GraphQL queries helps you to then think about how you shape your GraphQL queries so that you can, when you come to write the back-end part, you have a clear idea, what is the thing I want to call, and then I can now write it. So, and then I'll just show you the tests that use this, just, I guess, for interest, and I'm not sure if you can read all of this anyway. So there's the describe block. So I'm describing a component selector, and I mock the provider. This mock provider is the, sorry, I have to go back to the top, is from React Apollo test utils. So it's something that we've brought in, and I will share the link more about that information afterwards. So going back to the test. So we mock the provider, we set it up with the empty query, then we call the component. The thing we're actually trying to test is this component selector container. We give it a slot ID, but because we've set it up with an empty thing, it's going to return a nothing result. So we had to put some stuff in about waiting for things to happen. And then what we expect to see is that we expect to find a select, but and this is a bit not easy to see. If I can't show you the UI at the moment, but basically, if what you're doing is you then check and you find, oh, yes, I haven't got any options. I haven't got any options for this component selector. And then then the next scenario is actually a bit easier to understand, because if you try to create a component selector container, but you don't, and you give it an empty query with no slot ID, then it gives you a message saying, please select a slot. Because if you don't have a slot, you're not going to be able to get any results. And then the very last one is actually a query that will return some results. And when you do return some results, you expect to see the component names in your field, in your HTML that is rendered from the component. So that's an example of using a mock provider for GraphQL that enables us to write a unit test. This is not an acceptance test. It's not testing any endpoints. It's actually just all running within the front-end code. And at least it helps us to think about how we want to design our queries for when we come to the back end and then we write those queries. So that is that's basically where we learned all this from. So right, now I'm going to stop giving examples of tests and talk a little bit more, step away from kind of what are tests and how would you write them, to more like why is it that there were some people in the category of, yeah, I know what tests are, but I don't write them. And I would include myself in that category sometimes. So what are the trade-offs? So there are some obvious benefits. If you go to the bother, and I've been on projects where there is an obsessive desire to have tests for everything, it's great in a way because you can always be sure that you haven't broken any of the existing functionality. If all of the developers that have gone before you were really assiduous, wrote loads of tests, you can just add something and you go, oh, right, all the tests pass, it's working. Well, often that is a lie, and it doesn't. And there are still some cases that people haven't thought of, and so it's possible. But it does mean a big benefit is you get automatic checking. You only have to invest the time the once, really, in writing the test, and then many people can run that test. So given the example of my silly little component where it has to render once with an upload button or a trash bin, other people don't have to keep clicking around trying to figure out how it works. They can just run the tests and they can have confidence, oh, that's the basic idea of what it's supposed to do. And you can illustrate how what scenarios your component does address, and also it can be clear from looking at the tests, well, what scenarios doesn't it address? And often when you have a live issue, a defect, a problem to resolve, it can help you. You just add an extra test case and say, well, does it do this? I had an example today where I was trying to strip a bit off. When you upload this file to the S3 bucket, it then puts a timestamp on it, and I wanted to strip that bit off. And I thought I could just slice it on a hyphen character. What I hadn't bargained for is that there were hyphen characters in the URL, and then so it meant that it was cutting the wrong piece off. And so then I could just add a test, then I could be sure that it was working. And so those are the benefits of tests, but there must be some drawbacks, otherwise people would always be writing tests. So one of the hard things is it takes time to write tests, and sometimes it's pretty hard to get it to kind of set the code up in the situation that you want it to be able to test it. And sometimes it feels like the investment of doing that programmatically is not worthwhile, and you might as well just click, 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 right, reload the page. Is it there? Yes, it is. Also, one of the frustrating things can be is that you change something about an application and it breaks the existing tests, but it doesn't break them. I mean, the tests stop working and stop passing, but it's not because the application is broken. It's because they require new setup. So in the summer, I was doing some work on the job application form at TES, and we were doing some restyling of it, which shouldn't have broken anything because it was literally putting a grey background around various different sections. It was to make it look more visually exciting with this grey background. But it broke tests, and it was annoying and fiddly to work out why they were broken. And then you think, well, are these tests really adding any value? And sometimes what happens is people see some code and they want to clean it up, and then a few tests break, and they think, oh, I can't be bothered. And so sometimes the tests, although they are nice because they make sure you don't break anything, they sometimes stop you from improving the code. So there is it's like putting a little straitjacket around the code base, is that it sometimes means that it doesn't grow and evolve because people are kind of hemmed in by the tests. So those are some of the trade-offs to think about. In my view, I think it's worthwhile writing the tests when you're developing a thing and doing it in small steps. It doesn't necessarily have to be exactly faithfully write a test and then write the code and then write a test and then write the code. But I think it's worthwhile not building a very fancy component and then writing a few simple tests for it. I think it's worthwhile, and it can help you while you're in the process of developing something, because it helps you to shape your code. And it also can help, one of the things we found, and I'm only working in a team where there's 3 developers, sometimes we want to work on different pieces independently, and it's quite nice to be able to say, well, I'll take my piece, I can work separately from you, because I don't have to wait for your bit to be ready that's going to call my thing. So I've been working on the image uploader component, but I haven't had to worry about the thing that it's going to be used in. I can just write it with my tests. And then obviously it's worthwhile to do if you have non-trivial logic. So, I mean, I imagine we've all been in this situation where we've been looking at some code base and thinking, what the hell does that function do? And so having some tests does help you, because you're then able to see, well, what is the data supposed to... recently, I was working on some code and it was for filtering, but I couldn't tell whether it was filtering in or filtering out because of the naming of the variables. And it just would be helpful to have a test which goes, here's a set of 3 things, and when you filter them, they're one thing, or, you know, is it a filtering down or a filter... so anyway, it can help document your code, and it helps you to uncover edge cases. However, and since I've been moving to being a JavaScript developer, I've found that I often don't write tests as much as I used to. And often it's because it's fiddly to get them to set up. And if you're I don't mind spending half an hour or an hour setting up a test, but if it's all morning, then I'm thinking, no, probably it's not worth it. So you just have a sense of, is this taking too long? Also be aware of the thing that you're building. So is this something that's going to be kind of a keystone of your application you're building? Or is this just something where you're it's an interim way of how it's going to work, and then something else is going to be added? Because if it's not that permanent, then I don't think it's worth investing in tests unless you really feel that's going to give you an advantage. And then the last thing is, when you're working with React, for example, you're always trying to make things very simple, very obvious. You know, it just does this thing. You can just see there is no complex conditional logic path. And so therefore, if it's really simple, you shouldn't need to write a test for it. So there is that kind of case. So this is now my conclusion. I should have had something saying summing up or something like that. But this is... So I find that unit tests help me to shape the design of my code. They help me to think what are the arguments to this function going to be? What's it going to be called? Do I have to set up any relationships? How would I mock those out? So that helps you. It's a sort of software design practice. It also helps you to work on things independently. It's particularly unit tests help you with this. And it can help you think about the API for the back end before you write the back end. So again, it's another thing where you can work on things separately. And then just finally, it does always save you from constantly reloading the page and just say, oh, does it work this time? Does it work this time? It saves you time. And it usually saves your colleagues time as well. So that is the end of my talk. This is a little bit about Tez. We've got a Twitter account, and various engineers write blog posts and share them there. But anyway, that's all I have to say about unit testing. Thank you, and let me know if there's any questions.